Hello everyone, I think it's time to begin. Welcome to this webinar, which will give you a tour and overview of the new features in the AnyBody modeling system. So the outline for today, first of all, let me introduce myself. My name is Morten. I'm an R&D engineer here at AnyBody Technology, and I'll be your presenter today. Next to me here is Kasper Rasmussen, which he's a simulation engineer here at AnyBody, and he will be our panelist today, and he will try to answer questions during the webinar and participate in the questions and answers session at the end. The outline for today, first of all, is I'll just give a brief introduction on the AnyBody modeling system and what it can be used for. If there's any new people here who doesn't know what the AnyBody modeling system is. Then we'll talk about some of the new features in AnyBody, some features for advanced kinematics, features for working with inertial MoCap models. We also talk about some improvements in the AnyBody modeling system, which enables a lot of MoCap related things. We'll talk about better graphics in the AnyBody modeling system, and then finally I'm going to present the new community site, which just launched, and our new wiki site, and I'll present some of the future plans for the AnyBody modeling system in the end, and then we'll do a questions and answers session. So the AnyBody modeling system, first of all, what is it? Well, it's often think of it as two entities. First and foremost is of course the software. This is what you see on the left side. This is the actual software where you develop and run simulations in, you develop models in. But the AnyBody modeling system is also the AnyBody managed model repository, which is basically just a folder on your computer with a lot of models in. These are pre-built models from publications, different research groups around the world. Body part models which we've stitched together and tried to curate as best as we can. The AnyBody managed model repository is also a set of applications and small demo examples that can help new users get started. So what you would normally do working with the AnyBody modeling system is that you would normally start up with some of those models in the model repository, take some of those existing body models which represent many years of work, and then combine it with your own environment. This is basically what's shown here in the picture in the middle with an egress simulation. So what is the AnyBody modeling system used for? It's used in a wide variety of applications, from product design, economic analysis, surgical planning. You can use it to generate the load cases for final element analysis, basically generate the boundary conditions. But the AnyBody modeling system is also used for movement analysis, motion capture related experiments. A typical workflow in the AnyBody modeling system will look something like this. You would basically come up with some measured motion or maybe some external measured forces. You might also have your own environment model that you want to include in the analysis. This is on this page represented by this exoskeleton here at the bottom. And then you use some of those body models which has been created by different research projects. And then you combine all of these things into your own model. The next thing is to run simulations on these models. That's basically solving the muscle recruitment problem, running inverse dynamic simulations to get the internal body loads, muscle forces, and joint forces. This is what you see here on the screen. In some cases, this might be your end goal, but in other cases, you might want to export some of these things for post-processing, for example, in final element tools. And in some cases, you might want to close the loop completely. You might feed back your results to improve your environment model, and then you have like design loop here to optimize your product. This was just, oh yeah, I also want to say if you have your design outside, we have an exporter for SolidWorks so that you can export your environment models directly from SolidWorks into AnyBody. This could be a wheelchair as shown here, or a workbench, or even an entire model, or an entire car as shown here. And this makes it, of course, much easier to create these external models and use them in AnyBody. So this brings us to the actual content of this talk. What's new in the release? So we already talked about that there was these two entities here, the AnyBody modeling system and the AnyBody managed model repository. The thing that is updated in this release 6.1 is the AnyBody modeling system. The AnyBody managed model repository is still version 1.6, as you know. We're going to release a new version of this, but it will come later this year. Since we don't really release any new models, we will also, as part of this webcast here, release a few examples of new features for AnyBody. These will be standalone examples that you can download afterwards, and for you to try some of those new features that we're talking about. One of the features is a new MoCap framework. We also have an example of an inertial MoCap model. I've created a small AnyScript plugin to make it easy to make videos. We'll get to that when we talk about the graphical improvements in AnyBody. And there are also other few examples that you can download afterwards. So when you load up AnyBody 6.1, you might wonder what is new, because most of the changes are actually under the hood. You can find a detailed description of all the changes if you open up the directory where AnyBody is installed under Program Files. Then you go in under the folder called Documentation and Release Notes, and there you can find the Release Notes file. If you open that up, there will be an entry called New in this version, and that will list all the different features, bug fixes, and changes that are in version 6.1. It's a big document. And I encourage you to read those release notes if you want to get a complete overview. For this webcast here, we're only going to focus on a few things, and then we're going to present some examples that show some of those few things. Those things are the things we think is maybe the most important of this release. We're going to talk about a few of the new AnyScript classes for version 6.1. The first one is called AnykinMeasureFunCombi, and it's a way to create new measures in AnyBody. We're going to talk about the AnyInput BVH class for the AnyBody modeling system. It's a way to import BVH files and create inertial MoCap models. Then we're going to dwell a little bit on some of the language improvements for AnyBody. Not on the individual improvements, you can find those in the release note, but we're going to show you some of the things that these improvements has helped us with, especially a new MoCap framework that we have built and that we are releasing as part of this webcast. Finally, I'm going to show you a little bit about those graphic improvements that I mentioned earlier, and as part of this, I'm going to talk about this video creator tool that we've created. There's also some new licensing options in AnyBody 6.1. The most important one is that now you can run 4 instances with a single floating license. For people with the floating license option, that is quite significant. The previous limitation was a big problem, at least for some. You should just note that you will need a new license file to get this to work. But if you have maintenance, send us an email, and we will give you a new license file that allows you to run 4 instances of AnyBody on a single floating license. We also have started selling a new license type for batch processing. This might be the right license type for you if you are the kind of person who wants to run AnyBody without the graphical user interface to do batch processing on a supercomputer or something like that. Sensitivity studies or design optimization. This brings us to the class AnykinMeasureFunCombi, which is one of those new classes in AnyBody that allows some advanced kinematic features. The class basically is all about modifying existing measures. In this case, it will take an existing measure and wrap it with a function. And to really get an impression of what this class can do, we've created a small example here. So imagine we have this human body model here, a model here who keeps it balanced by keeping the center of mass above the feet. Now imagine there is some obstacle that comes toward our model. Basically, we want our model to dodge this obstacle. So we imagine there is this barrier at some certain distance from the human. If the obstacle is to the right of this barrier, we basically don't want any reaction. If the obstacle comes closer than this reaction distance, we want it to dodge. So we can imagine something like this. When it comes close, we want it to dodge. So in this thing, in this example here, we basically have the two components. We have our existing measure, which is basically the distance from our coordinate system here to the obstacle, and then we have a function. And in this case, the function is basically flat when we are on the right side of the dotted line. But when we get closer than the dotted line, the function rises sharply. So you can think of that we have on the x-axis here, we have the input measure, and on the y-axis, we have the output measure. So when the obstacle moves towards the person, let's see if we can show this again. As the obstacle moves towards the person, then the dot here goes up along the function. So what happens if the obstacle is closer than the reaction distance? Well, the optimizer or kinematic solver will basically try to minimize these measures here. So in this case, it will try to move this red dot down so it gets close to 0 again. And to do so, it will try simply to violate some of the other constraints in the model. So it will bend backwards so that the measure gets minimized. Let's try to show a small video example of this little model here doing the limbo. Oh, sorry, see if I can start the video. So we have the bar coming towards it, and he touches it. So the class is called AnykinMeasureFunCombi. You will write this in the code. The code will look something like this if you put it into the AnyScript class. It will contain a reference to some existing measure, and then some functions. I see here that I flipped the arrows here. But basically, an existing kinematic measure, as we saw before, and then a reference to some functions which can modify the measure. So the class can be used to transform existing kinematic measures and create new nonlinear relationships and nonlinear measures. One of the applications of this could also be to create joint limits, joint constraints on existing models, but you'll also show something with territorial constraints in the next example here. This is actually a model from my panelist here, Kasper, who made this as part of his master thesis. It's a model of a package design where the model is seated in the seat here with a hard constraint on the hip, on the H point of the hip. Then we have a number of not so hard constraints. Those are the constraints we kind of want to be fulfilled. We want him to grab the handle, we want him to keep his foot on the pedal, we want his back to be at the backrest and his head to be at the headrest. Then we have a number of constraints which are softer still. These are, you can think of these as the preferred posture of the human. And then finally we have our special constraints, the really soft ones. Those are the seat, that allow the seat to move back and forth and the wheel to move up and down. But in a package design like this, we cannot move the seat infinitely far back or the seat infinitely far forward. There will be some constraints on these. And this is where we have these territorial constraints. And these can be implemented with this AnykinFun class. So in this case here, the range of motion of the seat moving back and forward is basically constrained by some function that we have created. As long as the seat is within the range of motion, the value or output of this measure is basically 0, so the seat is completely free to move, and the And the model will basically choose whatever seat position fits the preferred posture. But if the seat comes back close to the end, the value of these kinematic constraints will rise sharply and the seat cannot move further back. So Casper used these kind of models to do big simulations with a lot of subjects, or populations, to see how would this car package design fit a certain populations. He ran thousands and thousands of models using this approach. Oh, maybe I should say that there is a webcast on this that you can find on our homepage, but we will get back to that later. The next example I'm going to show you here is an example of how to create inertial-driven MoCap models. These are MoCap models where you get the data from inertial sensor shoots. Here's an example from an XSense shoot. They use accelerometers and gyroscopes and these kind of things to give all the joint angles for the person. These kind of suits have the benefit that you can basically leave your MoCap laboratory to do experiments outside. When you export data from this, you usually get it in the format of a BVH file. And the AnyInput BVH is also an updated class in this AnyBody 6.1. Previously, it had a lot of disadvantages that made it really hard to do these kind of models, but these has been fixed now. So as part of this webcast, we are releasing an example model that will show you how to make a MoCap model based on these BVH files. So in itself, the AnyInput BVH class doesn't do much. All you have to do to use it is basically declare it in the model and give it a file name for the file you want to import. What it will do is it will create a kinematic stick figure model like this. It doesn't give you a full analysis, or it doesn't even include the human model. But it does give you a stick figure model with all the angles from the BVH file. To get a complete MoCap model, what you need to do is basically to put some markers on the stick figure model. Then we can generate the marker trajectories directly from the stick figure model and use those marker trajectories to drive our human model that we see here on the right. And then in the end, we can do our inverse dynamic simulation. The reason why we want to export the marker positions and not drive the human directly by the joint angles is that these virtual marker shoots usually generate some amount of noise, and filtering this kind of noise, for example with a low pass filter directly on the joint angles, is not a bad idea. You want to do these kind of things on position level, so that is why we export the marker trajectories first and then use those marker trajectories, or filter those marker trajectories and use those to drive the model. Finally, if you want to use these kind of things for inverse dynamic analysis, you also need the boundary conditions. You need some forces. In a normal MoCap experiment, you would basically get those forces from a force plate, like you see here on the left lower corner. But those force plates are not usually available when you use these suits or you go outside the laboratory. So in this case, you can use the feature in AnyBody to do ground reaction force prediction. We have a whole webcast on that, and I really encourage you to see that. It's really nice. But when you set all of this up, you can get models like the video I'm just going to show you. So in this example here, it's actually calculating the muscle forces. At the same time, it's doing the ground reaction force prediction for this human. Doing some sort of Tai Chi, maybe. So we released a whole example model of how to set this up, and at the end of the presentation, you will get some links on how you can get these kind of models to get started if this is what you want to do. We've also released a new framework for doing MoCap models. In the new release here, we have a number of language improvements for the AnyScript language. For example, updates to the class template system, the AnyScript parser. There's some changes and fixes to the AnyInput file, a class that loads in files. We've included features to exclude certain parts of the model. There's also a lot of features that has to do with the model view and hiding and viewing objects in the model view. And all of these features together has meant that we can able to make a new and much more improved MoCap framework. We recognize that some of our existing MoCap examples have been quite difficult to use, especially for new users, and also quite difficult if you want to do something special. As soon as you get marker dropouts, you really have to be good at AnyScript in order to get around these things. These are some of the things and difficulties that we have tried to address with this new framework. So we are releasing this framework kind of early in order to hope that we can build it up over time. Doing MoCap models are quite hard. There are a lot of marker protocols available, and we hope to get all of those marker protocols working over time. At the moment, there is an example in this framework for doing this with the normal plug-in gate marker set. It's easy to extend with new marker sets, but when we want to eventually include it in this model repository that is shipped with the AnyBody modeling system, we want it to be more complete than it is now. But for many users, this is way better than what is in the model repository at the moment. So that is why we are releasing this. This is also what we use internally. You can find it here on this link, but we'll also get back to this later. We're basically hosting it on GitHub. Finally, this is just a quick video from the MoCap model, walking over some treadmills. You see here the camera spins around the model. We'll get back to how to make these kind of videos in a second. But this brings us to the final part, the graphical improvements in the AnyBody modeling system 6.1. So from 6.0 to 6.1, a lot of things has happened with the graphics, mostly because of anti-aliasing of the model view. There's some improvements to the chart view. So previously the chart view would look something like this, as you see here on the top, but now it looks something like what you see on the bottom. There are a number of improvements to the chart view that will come out in the later releases, but for most part it looks much better, and it's much easier to include directly in your presentation. There's also some improvements to the actual model view where you see the human. This will basically enable you to get better videos when you make videos from AnyBody. Previously it was necessary to export the pictures in quite high resolution before you made the videos. That shouldn't be necessary now. So to illustrate some of those new improved graphics, I created this small camera plugin that I hope will enable people to make nice AnyBody videos. This has also been like a pain before because you had to export all the images from all the different frames in your simulation and then find some external tools to glue them together. But we tried to address this with this small tool here. It's basically an AnyScript plugin that you can use in any model. To use it, you will basically include this class template here at the top of your model. And then somewhere in your model, you would put in a block of code, like you see here. You would declare this class template. This is pretty much a minimal example of what you need to get started. You have to specify what the camera should look at, what global position it should look at, and from what direction the camera should look. And these variables here can be parameterized, so you can, for example, say it should always look at some position of a single segment and then the camera will follow that segment, or you can set up the look at direction to be a function of time, for example, and then the camera will move around the model. And I use this tool to create some of the videos that you have seen already. And this brings us to the end. What can you expect from us in 2017? Well, as I told you, the AnyBody managed model repository is not part of this release. This is because we're releasing it a little bit earlier, a little bit later, I mean. And in the model repository, there will be a new lower limb model based on the 20 lower extremity model version 2.0, which is part of the TLM Safe project, an output from that. There's also going to be a new thoracic model, which has been implemented. There will be an updated lumbar, spine, and pelvis geometry and pelvis model. And there will be a lot of new examples of this in this updated repository. You can also expect a release of the AnyBody modeling system 7.0. So in this new AnyBody modeling system 7, what the biggest change will be is that we upgrade the GUI system. So a new user interface. Some of the things will look the same. This is a screenshot from our internal version that we are testing at the moment. The biggest change I think people will like is the new tabbed editor for when you're developing models. It makes it so much nicer to work on many files at the same time. There will also be some chart improvements, new kinematic solvers. We are working on a plugin system so people can create Python plugins for AnyBody. And we are working on a software development kit so you can actually use AnyBody as an engine in a standalone application. Oh yeah, and in the new version you can also like move some of the model views and tabs and stuff to other monitors. So basically much more like a integrated development environment that you know from, for example, Visual Studio or similar softwares. This brings us almost to the end. I'm just going to point out that we've updated our community site. It came live yesterday with a new homepage. It's our community site where we will post tips and tricks for AnyScript. We also post when new models become available and these kind of things. But it's also the place where you find links to the forum, to our new wiki site, and to the repositories. And the repositories are those that we host on GitHub. I'll get to that in a second. So all of those examples that I've presented as part of this webcast, they are available on github.com/anybody. If you go in there, you find version control repositories of all these different examples. And you don't need to be able to use these version control systems like Git and stuff in order to use this. You can just go in, find the model that you're interested in, click the green button, and then download them as a zip file. But if you are able to figure out how to use these systems, you're also able to join the development and contribute back. We of course hope that some users will take advantage of that. And I think this brings us to the end. I will give the word to Kasper.
Thank you, Morten, for the great presentation. Before we go to the Q&A session, I would like to point your attention to our YouTube channel, where you can check out our previous webcasts. We also have our new AnyBody website, where you can check out events, dates, and publication lists. So if I go to the next slide, you can see our new publication list, where we've made this new filter tool that we really hope you're gonna like. All the publications has keywords, and you can see the different types of keywords in the top. And by clicking these buttons, you can filter by the keywords. So here we've filtered by lower extremity and gait related papers. So hopefully this is very useful. The AnyScript.org is where Morten mentioned that you can go, and from there you can find the wiki and our forum and these new repositories. We also have some events right now. The AOS is going on in San Diego, and right after that we are also attending the ORIS in San Diego. And then in the 19th April, you can see our AnyBody demo at Veracon in Phoenix. So this is wearable robotics and exoskeletons. So if you wanna meet us in general, please just send an email to sales@anybodytech.com.